Hello again, let's get started. We continue talking about construction surveying. Today's topic is azimuth and bearing. What are those? Let's get back to the definition of construction surveying or surveying in general, which is the science and art of taking measurements, either angles or distances, near the surface of the earth. And when we talk about measurements, we know that we need to have some references. Those references could be mean sea level or MSL for elevations, or north and south, or the benchmarks that we know, the elevation, or also the coordinates. Now let's talk about the coordinate system, right? Coordinate systems, we know that we have either geographic grid or geodetic grid. In the geographic grid, we assume that, or we map the earth on a flat surface or on a plane. But for geodetic grid, or the second coordinate system that you can see listed here, we assume that the earth is a perfect sphere. Then that brings us to latitude and longitude. Okay, so latitude are imaginary lines going around the earth, but longitude are imaginary also lines connecting the north pole to the south pole. Then by using these lines, or latitude and longitude, we can locate any point on the earth. Doesn't matter if it's in the ocean or in Africa. It's not Africa here, this is South America, but Africa here, Europe, Asia, whatever, it doesn't matter. Okay, we can locate those points. Today we're going to learn more about these, and we would like to know how these stuff work, how these stuff would help us as construction surveyors. And let's talk more about that. Okay, so for latitude and longitude, you see that these indicate some degrees or angles. So for latitude, if it is positive, that means that it is located in the north hemisphere or northern hemisphere. It ranges from 0 to 90 here, and 0 is the equator. Okay, you know that the equator is an imaginary line that divides the earth into two hemispheres, north and south. Okay, and it goes from one specific city that I don't remember the name of that. And if the latitude is negative, ranging from 0 to negative 90, that means that that point is located in the southern hemisphere. Similarly, we have longitude, which divides the earth into eastern hemisphere and western hemisphere. You know that the Europe and Asia and most Africa, these continents, are located in the eastern hemisphere, and the America is located in the western hemisphere. And these lines, or let's say the longitude, could range from 0 to 180, either negative, which means western or west, or positive, which means the east or eastern hemisphere. Okay, this prime meridian goes from one specific city again. I don't remember exactly the name of that, but you can Google, or I can also Google, and that it is Greenwich. So it is located in England, and the latitude of the city is 0. But you can see also that there are multiple cities that you can see. They are also located on the primary. Okay, let's watch a video that indicates the importance of latitude and longitude and how this would help us. Then I get back to the meridian and see what is meridian and what does the prime meridian mean. Here's the video from YouTube, latitude and longitude, that you can search and find it. I play it for you. It's quite interesting and very informative.
Earth, our home in the vast universe. The Earth's circumference is nearly 25,000 miles from start to finish. There are so many places on the Earth. How is it possible to precisely locate just one of them? For instance, what if I wanted to tell a friend the exact location of the Coronado Bridge in San Diego? It would be hard to describe, but give him the coordinates of the bridge and he should be able to find it quite easily. To find precise locations, parallels of latitude and meridians of longitude form an invisible grid over the Earth. Latitude. Lines of latitude, also known as parallels, circle the globe from east to west. These lines are all the same distance apart, about 69 miles. Each degree of latitude is separated into smaller pieces called minutes. There are 60 minutes in 1 degree. Similarly, each minute is divided into 60 seconds. The equator lies at 0 degrees, halfway in between the North and South poles. There are several other unique lines of latitude. The Tropic of Cancer lies at 23.5 degrees north, and the Tropic of Capricorn lies at 23.5 degrees south. The part of the Earth that lies between these lines is called the tropics. It's known for its hot temperatures, heavy rainfall, and dense jungle. The Arctic Circle lies at 66.5 degrees north, and the Antarctic Circle lies at 66.5 degrees south. The area of the Earth between these parallels and the tropics is characterized by 4 distinct seasons. Longitude. The lines that run north and south are called meridians of longitude. These lines are measured the same way as parallels of latitude using degrees, minutes, and seconds. However, unlike latitude, lines of longitude are not equidistant from each other. Meridians intersect at the north and south pole. 0 degrees longitude is called the prime meridian. It passes through the Royal Greenwich Observatory in Greenwich, England. Using latitude and longitude, the precise location of San Diego can be written as 32 degrees, 42 minutes, 54 seconds north latitude, 117 degrees, 9 minutes, 25 seconds west longitude. Parallels of latitude and meridians of longitude form an invisible grid over the Earth. This grid is measured in degrees, minutes, and seconds, and it allows us to pinpoint exact locations anywhere on the face of the Earth.
Now let's talk about azimuth, and start with azimuth. But before that, we need to know the definition of a meridian, or also called longitude. This meridian is a line. So it's a line, you know. Only need to know 2 points in there. It is on the surface of the earth and joining the north and south poles. Okay. So by definition, we know that a line, we need to only know 2 points. And you can draw a line going through those 2 points. And these 2 points are north and south. But because the shape of the earth, which is sphere, you can grab a ball and either a basketball or whatever and just look at it, and you can point 2 points to be north and south, and you can see that you can draw unlimited number of lines connecting north and south. As long as you are connecting north to south and it is a line, then it is a meridian. Okay, that's the meridian, that's it. Okay, now let's talk about the azimuth and what does it mean, or what is the definition of azimuth. Azimuth is the direction. It is the direction of a line. So what does it mean, a direction? A direction is like when you want to give an address to your friend, or Google Maps, or Google Maps give you the direction. Turn to the left, turn to the right, go straight, or whatever. Okay, it's the direction of a line. What is that line? It is any line that you use in surveying. Remember the polygons that we calculated or took some measurements, right? Any of these lines could be this line that we want to find the direction of that. But how we define or identify the direction of this line? It is by an angle. Okay, so referring back to the meridian and latitude and longitude, it is an angle. This direction is an angle. Okay, so 2 degrees, 10 degrees, 50 degrees, whatever. But how this angle is measured in surveying, everything needs to be measured from a reference. Okay, it is measured clockwise, so like clock, from north end of a meridian. So a meridian has 2 ends, north and south. We don't use the south end. We deal with the north end as our reference. And you know that, do you remember the different types of references that we use in construction surveying? The poles, north and south poles, were some of them. Okay, so it is measured from the north, it is measured clockwise, and then this is the line. So let's say I have an arbitrary line AB. Okay, so for a line it has 2 ends, AB. You know that when it comes to the direction, it matters if you say I am going from A to B, or you say B to A. Even though these are both 2 ends of a line, either AB or BA both indicate one identical line. However, we talk about direction right? We talk about direction. And in direction, it matters if you say I am going from A to B or I am going from B to A. So you need to make sure you pay attention to that. And in Azimuth and surveying, the first end, so if I say A to AB, the first end is indicates the starting point, and the second point or second end indicates the ending point. So if I say let's uh, erase all these, and I just put 8. If I want to find the direction of AB, that means my starting point is A. I am traveling from A to B. And I want to find that direction. So, in order to use azimuth, I need a meridian because it is measured from the north end of a meridian. I need to put or draw a meridian that goes through this starting point, in this case A. This is a meridian. Okay, let's get back to the earth. As long as one line goes or connects north and south ends or south poles of the earth, that's a meridian, and you can have unlimited number of meridians. Unlimited number of meridians. Those are imaginary lines. So for AB you can also draw a meridian. But what matters is that it is connecting north and south. And you need to know which end is north. Once you have the meridian going through the starting point and you indicated which end is the north end of the meridian, you need to measure this angle, the north end of meridian, to your line, and it has to be clockwise, because if you measure it counterclockwise, it will give you a different angle, and this is wrong. Okay, so this is wrong. I erase it. Has to be clockwise. This angle is what you're looking for. Let's say it is 100 degrees. So the azimuth of AB is 100 degrees. Okay. That helps us to draw the lines and find the locations of points. If I know where A is located and what is the distance of AB, let's say 10 meters, and then I have the azimuth, then I can find point B. Do you see how it would help you to find the directions and locations? It helps us to find the locations, the primary goals and functions of survey. Okay, it might first sound complicated, but it is not, I promise you. It's just the direction of lines. Think of you want to go from A to B and you need some direction, and your friend gives you, oh, can you find north? And you say yes, and then he or she says turn like 90 degrees clockwise and then start walking. It's like that. Okay, now let's see what kind of features or is there any more information that we know about azimuth. So by looking at north and south and measuring clockwise, by definition you know that it can range from 0 to 360. Both 0 and 360 indicate north, right? Because you start from 0 then you make a full circle that is 360. And you know south is 180, right? 180 degrees is south. But the point is, the azimuth ranges from 0 to 360. You do not have a negative azimuth. We do not have an azimuth greater than 360. Here are some examples. Let's say I want to find the azimuth for these four lines, K1, K2, K3, and K4. As these are shown here in this coordinate system. You see that there are four quadrants, and each of them are actually located in one quadrant. So the first quadrant, which ranges from 0 to 90, you know that always we go clockwise. The second quadrant, 90 to 180. The third is 180 to 270, and fourth, 270 degrees to 360 degrees. Okay. And we know that this vertical line connecting 0 to 180 is our meridian, because we know that meridian connects the north and south ends, or south poles. And north is 0 degrees or 360, both of them are the same thing, and south is 180. And you know that in all four lines, K is the starting point, because K1, going from K to 1, K2, K3, K4. And for all four lines, the meridian goes through the starting point, which is K. Let's take a look at the first one. For the first one, K1, the angle between K1 and these vertical or y-axis is given, and that is 10 degrees and 20 minutes. So that makes my calculation pretty easy, because I know that an azimuth is a direction, which is expressed as an angle measured from the north end of a meridian clockwise. And this number, or this angle, is exactly the azimuth that I'm looking for. So it would be 10 degrees and 20 minutes. How about the second one? The second one is located in the second quadrant, and I know that it is greater than 90, less than 180. And there's some information that is given, and that is the angle between these, let's x-axis, or let's call it east, and this K2 line, and that angle is 18 degrees 46 minutes, right? Is it my azimuth? No, because get back to the azimuth definition. It's the direction of line expressed as an angle measured from the north end of a meridian. So I'm looking for this blue arrow. I need to calculate this one. From 90 to K2 is given to me, 18 degrees 46 minutes. And I know from 0 to 90, or the angle of the first quadrant, which is 90 degrees, I simply need to add them together to make it, to measure this angle, which is angle from the north end of the meridian to my line measured clockwise. So I just add them together. 90 plus 18 gives me 108 degrees 46 minutes. That is K2. Very easy, straightforward. How about K3? K3 is located in the third quadrant, and some information is given, and that is the angle between the south end of the meridian and the line. This is helpful, but this is not the azimuth. I need to do some calculation because by definition, an azimuth is measured clockwise from the north end of the meridian, which means I need to add these 180 degrees, right? It's pretty obvious. I add 180 to 38 degrees and 7 minutes, and that gives me 218 degrees and 7 minutes. Okay, how about the last one? The last one might be a little bit tricky. Okay, the last one might be a little bit tricky because the angle between this line K4 and the north meridian, the north end of the meridian is given to me, and that is 25 degrees 25 minutes. But it looks like it is not my azimuth. What is the problem? Let me erase all these to make it easier. Okay. So this is given. This is the angle between my line and the north end of the meridian. But pay attention that this is not clockwise. This is counterclockwise. What I'm looking for is this big arrow, the short one. The difference between these two arrows is that the big one is measured clockwise, the small one is measured counterclockwise, even though both of them are measured from the north end of the meridian. So I know that they need to add up to 360, right? So what I need to do this time is subtract from 360. I write it as 359 degrees, 60 minutes, 25 degrees, 25 minutes. That gives me 35 minutes and 334. 34 degrees, 35 minutes. That's my azimuth. Okay. This is very interesting topic, reversed azimuth. But it is very straightforward and very easy. Reversed azimuth, you remember this line that I told you, AB? And I said even though AB and BA both give you the same line, they define the same line, but when it comes to the direction, it's different. If I tell you go from A to B or B to A, but it looks like they have some relationship. These are always the opposite direction, right? So the direction of AB is the opposite direction of BA. And that's the same thing for BA. The direction of BA is the opposite direction of AB. Okay? And when it comes to opposite, just imagine wherever you are sitting or standing or you are right now, pick one direction. Okay? Pick one destination. Pick one destination to go. It could be a corner of your room or whatever. And then just think, or you can start walking to that point. And then come back. You see, when you come back, you have to turn around for 180 degrees. And that is exactly the concept of reversed azimuth. Reversed azimuth is the opposite direction of that line. So always the azimuth of K1 is equal to reversed azimuth of 1K, or the opposite direction. Okay. And how to calculate it? It's easy. If it's greater than 180, subtract 180. If it is less than 180, add 180. Okay? You only deal with 180, either adding or subtracting. Add if it is less than 180. Subtract if it is greater than 180. If you do the opposite, let's say, for instance, you forget, do I need to add or subtract? If it is less than 180, you have to add. But if you instead subtract, you'll get a negative number. But you know that by definition an azimuth ranges from 0 to 360. Same thing for greater than 180. If it is greater than 180 and you do not subtract, instead you add, you'll get a number greater than 360. You know that it is incorrect. You know that it is wrong. So now let's take a look at this. You know K1 is 10 degrees and 20 minutes. How about 1K? 1K is when you put the coordinates on 1. And then you see that there are two parallel lines, one intersected. Then these two, let me choose a different color. So you know that these angles are equal. And measuring the azimuth of 1K is just adding this 180 to this angle, which is the azimuth of K1. So I need to just add 180. It is less than 180. It is it's going to be 190 degrees 21 minutes. So the reverse of K1 is 1K, and the reverse of 1K is K1. And now you can also calculate the reverse of 1K. Greater than 180, you subtract it, that gives you the answer. Let's review some examples. But before that, review the definition one more time. It's the direction of a line given by an angle measured clockwise from the north end of the meridian. That's the azimuth. An azimuth can range from 0 to 360 degrees. So for an imaginary line, AB, you can put the coordinate system and then measure. In this case, AB is from the north end of the meridian, and it is 50 degrees. Okay, this is north. I measure clockwise, and that gives me 90. How about this one? Still, we measure from north clockwise. So you can just read these angles right here, right? So it is 120. I highly recommend you to pause the video, answer the question, and then go to the next one. If it is on west exactly, it is from A to B, it would be 270 degrees. Here in this case, it is 308 degrees. Okay, always measure clockwise. And take a look at the reverse azimuth one more time. You know how to do that. Now find the reverse azimuth of these lines. So what is the reverse azimuth of AB? It is, so the azimuth of AB is 270 degrees. So the reverse is, because it is less than 180, I'm sorry, it is greater than 80, we need to make it less than 180. We need to subtract. That gives me 90 degrees. Or it is going to the opposite direction. Or BA, which would be 90 degrees, right? How about this AB that was 50 degrees? So it is less than 180. I need to add 180 degrees plus 50. That gives me 230 degrees. Let's see. Yes. If you go the opposite direction, 230 degrees. How about this one? That was 120, right? 120. 120 degrees. Is it less than 180? Yes. So you added 120 plus 180 degrees. That gives you 300 degrees. Okay. Reverse means going the opposite to the opposite direction. This is AB one more time. So BA would be 90 degrees, right? this is BA one more time. This is AB one more time. So the opposite would be 270 minus 180. That gives you 90 degrees. Now let's talk about the bearings. Today we talk about azimuth and bearings. Bearings is something similar to azimuth with just some small differences. Let's take a look at the definition. Bearing is the direction of line. Again, it's the direction of line. Given by the acute angle. What does that mean? Acute angle means it is less than or equal to 90 acute angle. Okay. And a meridian. Still, we talk about the meridian. We deal with the meridian. We talk about the direction of a line. Still, we talk about an angle. But the difference, here are the differences. First of all, the angle has to be acute. An acute angle. Second, it doesn't talk about which end of meridian. So we have the choice to either pick the north or south. Is it arbitrary? No. We have to pick a choice accordingly to make this angle to be acute. Does it matter if I measure clockwise or counterclockwise? The good news is no. Bearing could be measured clockwise and counterclockwise. That's great. And from the north or south end of a meridian, we have the option accompanied by the letters describing the quadrant in which the line is located. Think of the quadrant, right? So if it ranges only from 0 to 90, you can see that within each quadrant it could be the case. So if you just say this angle, let's say 45 degrees, it could be this one, the first quadrant. Let me pick a different color. It could be this one. 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 Because if you measure from the north for this one, it is measured from one end of a meridian. It is measured from a meridian. It's an acute angle of 45 degrees. And doesn't matter clockwise or counterclockwise. That's the case. Similarly for this one, these two, these are measured from the south and this one from the north. So we have to indicate which quadrant it is located. Either northeast, southeast, southwest, and northwest. Okay. Typically, even though it looks a little bit more complicated, typically my students found this bearing easier. Okay. So it just needs practice, and then you can learn the bearing. So for the first and fourth quadrant, because these are closer to the north end of the meridian, or located in the north, you measure from north in order to make this angle to be acute, and if they are in the south, you measure from the south end of the meridian. Here are some examples, and as you can see, these results are already given. But let's take a look at the first one, K1, the same lines. This time we want to indicate or find the bearings. For K1, this angle is given 21 degrees 40 minutes. It is measured from the meridian. It is an acute angle. As long as it is an acute angle, it is measured from the meridian. I'm good. So 21 degrees 40 minutes. The only thing that I need to put is indicate the quadrant, northeast. So it would be north, 21 degrees 40 minutes east. Boom. How about the second? This angle is given from the east. I'm not looking from east. I'm looking from either north or south end of the meridian. What should I do? They know I'm looking for this question mark arrow. this arrow with the question mark. I know that if I add these together, they add up to 90 degrees. In other words, if I want to find the bearing of K2, I need to subtract it from 90. If I subtract it, it gives me 71 degrees, 30 minutes. I only need to put these quadrant letters, south 71 degrees, 30 minutes east, boom. Why I couldn't use these 18 degrees directly? It's an acute angle. Yes, it is an acute angle, but it is not measured from meridian. This one is measured from meridian, and it is an acute angle. Boom. How about K3? K3. This time, this angle is given 79 degrees, 22 minutes. Okay. It's measured from west. That's not something that I look for. I'm looking for. I need these question marks. Similarly, I need to subtract from 90 degrees. That gives me 10 degrees, 38 minutes. It is measured this 10 degrees and 38 minutes. It is measured from south. It doesn't matter clockwise or counterclockwise. As long as it is measured from south or north and it's an acute angle, that's my answer. I only need to put this SW to indicate it is located in the third quadrant. South 10 degrees, 38 minutes west, boom. And the last one, this is easy. This is easy. It's a piece of cake. So this angle 66 degrees and 50 minutes is given. It is from north. It's an acute angle. Boom, that's my answer. No more calculation, just don't forget the letters. North and west, the quadrant. Okay, that's very easy. How about the reverse bearings? The same concept. Reverse means going to the opposite direction. Going to the opposite direction. Let's take a look at K1. K1, the azimuth is 21 degrees 40 minutes, measured from north. If I want to find the bearing of 1K, I need to put the coordinate system or move it and put it on 1. And I know two parallel lines, one intersected, so these two angles are equal. And this angle, 21 degrees 40 minutes, for 1K is exactly the bearing. So I only need to switch the coordinates or these letters. So K1, if K1 is north 21 degrees 40 minutes east, I just made north to be south and east to be west. And I kept the angle. No more calculation. 1K, which is the reverse of K1, is south 21 degrees 40 minutes west. That's pretty easy, right? So when you want to find the reverse of a bearing, you just need to keep the angle and make north to be south, south to be north, west to be east, and east to west. Just the opposite direction. Okay, instead of north, south, south, north. Make west to be east, make east to be west. And that's it. That is it. Very easy, very straightforward, very simple. I'm gonna do more sample questions on bearings, but I think that should be good enough for today. Good stuff on azimuth and an introduction for the beer. Okay. Next session I will continue discussing these bearing and learning more about the coordinate system. And as always, if you have any questions, feel free to ask. And I would encourage you to come to the quiz review sessions if you have any questions, or if you don't, there's some conflict or whatever reason that you have, watch the recorded video, Even if you have some other questions, feel free to email me or come to the office hours online.